Hello everyone. So today we are going to talk about this worksheet. So here in unit 1 we have some information about the classification of amine and alcohol. As you can see here, in organic chemistry the functional group can be classified as primary, secondary and tertiary depending on the way they link to the other carbon atom with the molecule. For example, amine can be classified as primary, secondary, tertiary depending on the carbon or atom bonded to the nitrogen. So what does it mean? It means if nitrogen is bonded supposed to be one carbon, then that will be primary amine. And if nitrogen is bonded with two carbon, then secondary. And if nitrogen is bonded with three, then tertiary. Clear? Whereas the alcohol classification depend on how many carbon are linked to the carbon bearing hydroxyl group. It means, suppose I am saying we have this alcohol. So the classification of alcohol depend on carbon bearing to the alcohol and how many carbon linkage to this carbon. So as you can see we have 3 linkage. So this alcohol would be a tertiary alcohol. So now we are going to apply this information in the question number 1. So identify to which class of the amine an alcohol belongs. So you can see this is the carbon bonded to the alcohol and this carbon bonded to one carbon and this one. Okay, so overall 2 carbon. Do not count double bond as 2 time or 3 time with triple bond. So you have to just look at the carbon neighboring to the carbon here. So it has 2, so alcohol is a secondary alcohol. And for amine, you can see it is in condensed form. So if you are going to expand, this is twice methyl. So we can do like that. So now you can see this nitrogen has 3 carbon. This one also carbon. So this is a tertiary amine. Clear? So alcohol is secondary, amine is a tertiary. So amine is a tertiary, alcohol secondary. Clear? Option number B is the right choice. Clear? Here again the same thing. Nitrogen bonded to 3 carbon, one here and one here. So tertiary amine, and this alcohol containing this is the carbon and this bonded to the 3 carbon. So this is a tertiary alcohol as well. So amine tertiary, alcohol tertiary. So both tertiary in option number C. What is the molecular formula of the following compound? We all knew carbon valency is 4. So every dot is a carbon. So carbon, 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 carbon here as well. Now we all knew its valency is 4. So we can add hydrogen. So here we can add 2 hydrogen. Here we can add 2 hydrogen. Here we have 2H. Here we have 2H. And that's it. Here we have already 4. Here 4. Here 2H. This one. This one. This one. 4. Here 1H and here 3. So now we can count. You can make a circle, So carbon is quite simple. 1 and this is 5. So 5 1 6. 6 6 12. 13 and 14. So carbon is my 14. Hydrogen 2 to 4 to 6 to 8 10 12 15 16 18 20. So H is 20. Clear? So I think it should be A. Isoamyl acetate is a honeybee pheromone that is released on the skin when a bee stings its victim. This pheromone has a sweet smell, attracts other bees to join the flight. The structure of... So this is a very straightforward question. We have to identify this functional group. Because this is normal carbon chain, so carbon is not a functional group. Look at this carbonyl group. This and this. So this one is a very basic thing. So you should know the structure of this functional group. So this is RC double bond OR. And we have done in the class as well. So this is ester. Okay. So this is ester. Ether is basically ROR. And carboxylic is RCOOH. And alcohol is only OH. A substance is classified an opioid. It contains aromatic ring bound to a quaternary carbon, which is bound by a 2 carbon to a quaternary amine. So it's saying opioid can be a first aromatic ring, and this is bound to a quaternary carbon, and there is a 2 more carbon, and this nitrogen is a tertiary amine. Okay, so this is opioid. This is the bonding pattern of the opioid. How many secondary carbon are present in the above structure? So if you want to figure out the secondary carbon, so secondary carbon means a carbon is surrounded by 2 carbon, okay, the direct 2 carbon. So you can see here, this carbon is bound to a 2 carbon, one here, so this one is a secondary. This one also secondary, this one secondary, secondary, secondary. This is a tertiary carbon, okay. This is quaternary, primary, primary, secondary, secondary. Clear? So how many secondary you have? 1, 2, 3, 4, 5, 6, 7. Clear? So I think it would be 7. Classify the molecule as being opioid or not. I told you already, aromatic ring bound to a quaternary carbon and then 2 more carbon, and after all we have a tertiary amine. So you can see here, where is the aromatic ring? This is aromatic ring, and it bound to a quaternary carbon, this carbon, okay. This is a quaternary carbon, and we have 2 more carbon, one here, and this is a tertiary amine. Clear? So this is opioid. Here this is aromatic ring bound to this carbon, this is a quaternary carbon, and 2 more carbon, and this is a tertiary amine. So X and Y both opioid, okay. What is the minimum number of carbon atom that an opioid must have? So this one is a opioid structure. Here you have to figure out the number of carbon atom. So we all knew every dot is a carbon. So how many carbon we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 carbons. And how many tertiary carbon are present in structure X? This is the structure X. We have to find out the tertiary carbon. So tertiary carbon means a carbon must have 3 carbons directly bonded to that. So this one, is a tertiary because 3 carbon. This one is a tertiary, and this one is a tertiary. Okay. This one is not a tertiary, okay. This one is not a tertiary because one bond is bonded to a nitrogen. So how many we have? This is quaternary. So 1, 2, and 3. I think it should be 3. So tertiary would be 3. Okay, so this is all about the worksheet 1, and thank you so much everyone.